A network of femtocell is an all-wireless mesh network which provides multi-hop connectivity among home nodes B, mobile nodes, and the cellular core through special nodes called local femto gateways. This video explains the making of the network of femto testbed, which is dedicated to the proof of this concept using off-the-shelf technologies. This picture presents the main building blocks of the testbed that has been deployed in the first floor of the CTTC building. Three are the main parts of the platform: the mesh network, the cellular system, and the experiment infrastructure given by the extreme testbed of the IP technologies area of the CTTC. More in detail: 12 multi-radio IEEE 802.11 mesh routers, 12 SagenConf femtocells, 1 for each router, a new MTS core network emulator, a packet gateway to the Internet, 20 3G user equipments, the extreme testbed tools that allow dynamic and flexible experiment configuration and management. So far, every mesh router is connected to the UMTS network emulator via the UH interface. In the final architecture, wireless routers will be connected via an 802.11 mesh network to a local femto gateway, which will be connected to the UMTS network emulator via the UH interface. Now, we are going to show step by step the procedure for the integration of the different parts of the platform. The first thing to be done is to register the SagenConf femtos in the cellular core network. To do it, we raise the radio and RNC layers from the command line interface of the femtocell. The registration process of the other 11 units composing the testbed is completely identical. These messages show the registration signaling exchange between the femto and the core network. The registration procedure is completed, so the first unit is ready to start accepting cellular users on its coverage area. Now, let's show how an user equipment is attached to the network. Let's plug the UMTS HSPA data card in the laptop. Automatically, the UE sends the request message to the network that recognizes the IMSI previously registered in the core network emulator. The messages captured by the emulator show that the UE has been correctly registered and attached to the 3G network. Now, let the UE request a PDP context to start a data session later. Again, messages show the signaling between mobile node and the core network. Once the procedure has been successfully completed, the mobile node has a new point-to-point connection available with the packet gateway, and from there to external networks. To test the external connectivity, let's generate a synthetic UDP downlink flow of 1 megabit per second between one node in the lab and the UE. Wireshark displays the UDP packets coming into the 3G interface of the mobile node, as well as the obtained throughput, which is 1 megabit per second as expected. This is just the preliminary stage of the network of femto testbed implementation. Wireless connectivity among mesh routers, routing protocols, load balancing procedures are other features that will be inserted in the future.